my great pleasure and honor to welcome here at our regular seminar Professor Nicholas Escher. It's not only our regular seminar, but also the series of the Jelinek, for which we invite every year 2-3 prominent people from other countries to give a talk. So today we have this regular seminar combined with FJelinekSeries. Professor Escher, at least I know him from the University of Texas, Austin, but I don't know for how many years, but for several years he has been now in France, in Toulouse, and working in a research institute of the National
Center for Scientific Research,
French National Science Foundation. I am very happy that he is here because I think most of us have not just once used a reference to some of his papers or some of his talks, especially those who work on discourse. And today he will talk on annotation and learning models of discourse structure, and I think this is a great occasion for us to listen to you and to listen to see what's going on. So
okay.
Please.
Well, thank you very much, Eva, for inviting me. Thank you all for coming. I've seen some of you, in various conferences, most recently the cost action. And so there are too many slides here, but I wanted to talk about, Oh, you're not supposed to do that. Oh, yes, because I forgot to plug him in. Sorry about that. There's sort of two sets of issues that I want to talk about. So I've been, as many of you know, I've been working on discourse and discourse structure, the theory of it for now many, many years. And I've now been doing quite a bit of computational work with these colleagues on discourse parsing, on finding full discourse structures for texts, which is a very difficult problem. The theory part I feel really very comfortable with. The empirical part, you'll see, there's a kind of hurdle or a wall that we're running into. I think the moral will be, for me the moral is we're too closely tied to syntactic models of parsing. Something else is going on, and there's a barrier beyond which we don't seem to be able to go. After all, discourse structure is supposed to carry a lot of semantic information, and when we think about it, we use deep semantic information, entailments that lie beyond the reach of computational methods right now. Okay. But I've also been working a lot on dialogue. Another issue is to do these, to learn discourse structures, the only way we really know how to do this, in comparison to lexical semantics, where I've also been doing some computational and theoretical work, is we have to use annotated data. We need to do supervised learning methods, not unsupervised learning methods, because the structures are too complicated, and we don't have enough data. I'm going to talk a little bit about the annotation processes, some questions that we've run into and probably you've run into, and I'd love to hear about what you're doing too, so that we can exchange ideas about this. And I'll talk a little bit about the learning, and I'll show you where we've gotten. And then I want to talk about another area which has a very, it's not text, it's dialogue. And we I have been fortunate enough to have a grant which has allowed us to construct quite a large corpus of chat dialogues, which are fully annotated with discourse structure. It's about 3 times the size of the RST corpus. It's not as big as the Penn Discourse Tree Bank, but as those of you know who work on it, there aren't full discourse structures there at all, right? We actually don't know what the full discourse structure even looks like. I'll show you what I think they look like in a minute. Okay, and dialogue has its own set of problems. I mean, chat is a different medium from written language, but it also has some interesting structural principles that may allow us to advance further. And you'll also see in dialogue, especially in multi-party dialogue, that you can just throw tree structures for discourse out the window. Okay. Okay, so let's talk a little bit about what discourse structure is. You know, for thousands of years, people, I guess at least since Panini, have thought that a sentence is not just a bag of words, right? A set of words where you allow repeats. But, you know, semanticists for a very long time really didn't think about something beyond the sentence until we started doing dynamic semantics. And even there, in dynamic semantics, what's the view of a discourse? It's just a sequence, right? Each sentence is in a sequence. Each sentence defines a transition on the information state and gives you a new information state. But discourse structure is much more complicated than that. And it has some kind of hierarchical or recursive structure. It's got basic units, and you can build up more complex things. And what are some of the features of this structure? Well, one of the things is that we have something like coherence relations, discourse relations, rhetorical relations. They come under many names, but what they do is they put bits of the discourse together in semantically interesting way. So here's a relative clause. John fired the man who embezzled the funds. What do you conclude about that relative clause? Right? Is it at the same time? Is he embezzling the funds at the same time he's fired? No. You use deep semantic information here to infer that the embezzling occurred prior, and it's actually the reason why he was fired. There's also structure. Look at these 2 sentences. I've just given you here some constructed examples. Mary gets stuff done because she's organized. John doesn't because he doesn't. 2 ellipses, common in English. Where do these ellipses go? If you just think of sentences as sequence, right? I'm not going to tell you, but there's a kind of contrast here, right, between Mary getting stuff done and John is not getting stuff done. If you want to maximize that contrast, you're going to resolve this ellipsis to this part, and you're going to resolve this ellipsis to that. But you're just going to take the VP is organized and the VP getting stuff done. Okay? So there's structure there. These 2 sentences actually have a discourse structure in them. It's signaled by this discourse connector, this little trigger. And then these 2 structures go together in a certain way that tells you how to resolve those ellipses. And if you don't take account of that structure, you don't have an account of ellipses, at least in these complicated cases. And, you know, over the past 22, 23 years, 24 years, you know, there's been a lot of evidence that shows that this kind of structure has semantic effects on pronominal anaphora. I'll just refer you to the work of Andy Kaler on that, where he's done psycholinguistic experiments on that. Has effects on scalar implicature, something I've written about. It has effects on the treatment of presuppositions, on temporal structure, and on and on. So it does seem to be important for semantics. Now, are there any constraints in here that we can dig out? Or is it just a free-for-all? Well, the way colleagues and I have defined what we think that discourse relations, discourse structure, is a key to coherence. When is a story coherent and when is it not? Okay. And we think that in a coherent discourse, every one of these basic units, elementary discourse units, except maybe one, the top one, maybe the topic or the initial one, should be linked to another via some kind of coherence relation. And then we have some questions that various theories will try and answer. So, can substructures of the discourse serve as arguments of coherence relations? I just showed you an example that would seem to indicate yes, the one about ellipsis. But some theories won't do that, and I'll show you one. What about attachment principles? Where can we attach new information if we think of building a discourse structure incrementally? And you'll see that we really can't do that in a very good way right now. Where should new information attach to a given discourse structure? Does it have to attach to the preceding element, as dynamic semantics would sort of have it, right? That things just come in a sequence. So sentence 2 attaches to sentence 1, sentence 3 attaches to sentence 2, sentence 4, and so on. That's a very simple attachment principle. You can call it attachment to the last element introduced. Or you could have long distance dependencies. And if you look at corpora like the RST tree bank or the things that we've annotated with SDRT, you'll see there are long distance dependencies. Somewhere around 35 to 40% of the attachments are outside the sentence and beyond the previous sentence. Now there might be some principles about where you can attach. So these discourse structures are built, when they're built up, you can think of them in terms of a graph, and you could think of distinguished portions of that graph as being primary attachment points. And that's what something like the right frontier constraint in SDRT tells you. There are also some very interesting constraints for dialogue. So we know that in text, we can see this with syntactic subordination, which often, but not always, parallels discourse subordination. So, I could say, although I'm tired, I'm enjoying very much I'm enjoying my lecture in Prague. At least I'm enjoying it. And that although that subordinate clause is dependent on the main clause, right? But it's a kind of a backwards link, right? So I'm actually, when I give you that concessive clause, you're kind of waiting for the main point. That's what we might call a backwards attachment. And they happen quite a bit in text, but it's very hard, and when you think of a dialogue, or when people are like, our corpus is about negotiations, I'm going to react to what you're saying. I'm not going to answer your question before you've given the question, or I'm not going to accept your offer before you make the offer. Okay? So turns, because dialogue is very much a reactive kind of construction, a reactive activity, you have quite a strong constraint. Something like, it should be very rare that somebody in turn N has a backward link like the concessive that I had to turn N plus M by another speaker. It's almost impossible. I don't think we have any in our corpus. We have 11,000 discourse relations now in there. And we haven't found a single one. Okay. So those are the constraints. Oh, and then the last question that you might ask if you're thinking about a theory, but also about every annotation manual actually has behind it a theory. Okay? And so when you're writing your annotation manual for doing discourse, you're implicitly answering these questions one way or the other. So let's now look at a single, unit. How many incoming edges to that EDU can there be? Another way of asking that question is how many rhetorical functions or discourse functions can a single unit have? And here's an old example of mine. We heard a little bit about this at the cost workshop from Oh dear, that student of Andy Kaler's who's now at Edinburgh. Anybody remember her name? She gave us a talk about these things. Here we have two, right, discourse connectors. One should mark contrast, right? Well, what's then doing? It's marking a relation too, right? We bought the apartment, afterwards we rented it out. But there's also a contrast. So if you take these multiple connectives seriously, it looks like, oh, why are you doing that? You silly computer. This doesn't seem to have any power to it. I might need a little technical help, sorry. Maybe there. Maybe it'll go there. There it goes. Okay. It's fine. Sorry. Yeah, sorry. So here it looks like this renting it out has two incoming edges from this one. But now you can imagine incoming edges from several sources. And you're going to see some of those in a minute. When we come to dialogue, they're very common. Okay, so now there are lots of theories out there on the market. You could just sort of throw up your hands and say, we're never going to make any progress because everybody's working in their own corner and, you know, we can't talk to each other. And, you know, somebody, at some Amsterdam colloquium, somebody said, well, you know, discourse structure looks like a train wreck. Well, it kind of is a train wreck, but so is a lot of other science. It's a productive train wreck is what I want to say. We do have lots of different theories. So SDRT does allow these multiple incoming arcs. We're happy with it. Those examples, but then they're fine. That means we don't have tree structures, right? Because you have two parents for a given node. We also have complex discourse units functioning as arguments to relations, and we have the right frontier. Something like GraphBank, which not many people are using today, and you can sort of see why. This is the Wolf and Gibson MIT theory from around the beginning of the 2000s. They basically just have multiple arcs. It's just a pretty much free-for-all graph. There are discourse dependency trees, which look very much like syntactic dependency trees. They're computationally nice. So we've used them, and also there was an ACL paper on these. They are tree structures, but they do allow for long-distance dependencies. And then you have RST, where you really have if you read the manual, you know, Marku over and over and over again tells you adjacency, adjacency, adjacency. Anytime you take a relation, you better pick spans for the two arguments that are adjacent. Okay, so that ensures trees. There's only a unique incoming arc. It's unclear whether they have CDUs, but I think they do. Very strong right frontier constraint, and it's unclear whether they have long distance dependencies. Okay. And then there's DL tag, which is also a syntactic theory which uses trees, but you know, it has some wiggle room so that you can do some of these long distance dependencies. Okay, so you know, the first thing you want to ask when you see all these theories is, okay, how did the structures compare? And once we know how they compare, we might ask ourselves, can we translate from one corpus to another? That would be extremely useful, right? First of all, because you can train on one corpus and test on another to see whether anything carries over. You have a lot more data, and you know this data is extremely expensive to come by. I don't know about with your Czech tree bank, but if you're paying your annotators, or if you're not and you're suffering and doing it yourselves, then you know there's a cost, maybe not in terms of Czech crowns, but in terms of sanity. So it's better to have more data until we figure out how to do this in a non-supervised way, if ever. Oh yeah, so I'm gonna make the claim. Now Bonnie came up to me after my talk at COST, said, oh, they're not dependency trees, but I did convince her that if you just look at the connected bits in the PDTB, what you get are just a sequence of dependencies. Okay? And so they're pretty close to those. Okay, so I did give an answer at cost, at least a little bit, about how to answer question one. I'll go over that rapidly. But first I want to say a little bit about this. All right, so once you choose one of those theories, you're going to have a corpus that's going to look pretty different from another corpus. Okay? The RST corpus looks really different from the PDTB. Okay? But you might still want to do certain kinds of tasks, like do you want to learn full structures? Do you want to annotate full structures or not? Now the thing that we really concentrated on in order to figure out how these various theories relate to each other, we really took a semantic point of view. Well, that's because, well, I'm a linguist, at least, have been for many years. I'm getting too old to change. So I want to know, because I see that discourse structure has semantic effects. I want to know some basic semantic questions like, what is the scope of this relation? What are its arguments? Okay, no, you do that, you annotate that in PDTB, but if you look at RST, it's not clear. Right? In RST, you might need something like nuclearity to figure out what argument scope is. Okay? All right, so I'll just go on. I've made enough. Okay, so I told you that what we're interested in is, right, the semantic scope, right? So we need to know about some sort of bijection from one structure to another between the relations. And there are two possibilities for reading scopes from representations. One is what you see is what you get. And that's what you get from logic or from Montague grammar, right? If you see, loves John Mary, you know what the scope of loves is. And if I say John Earth is flat, you know what the scope of say is, okay, over that proposition. That's a what you see is what you get kind of approach, and that's what we do. Now, in RST, you actually have to compute it from the structure, and I'll show you. And I guess from, in PDTB style annotations, you folks are in the business of annotating what the arguments are for each one of the connectives. Okay. So I'll just give an illustration of SDRT. So what is a SDRS? Which is our discourse representation structure with the structure in it. It's a directed acyclic graph where every discourse unit is a vertex, and we have two sets of edges, directed labeled edges for the rhetorical relations, and directed unlabeled edges, which tell you for the complex discourse units what their constituents are. And we have two different kinds of relations. But this means that this is part of the machinery for getting what you see is what you get. And so here's the example that I showed also in cost. So a French example, this is from one of our corpus setups, from one of our annotated corpora, Anno 10. It's about principles of natural selection, The theory of natural selection, insofar as it was initially described by Charles Darwin, relies on three principles. 1, 2, 3, okay? And here we made a kind of complex structure. So pi 1 is this top little label. It's almost like a title, but it's what the rest of this thing is going to tell you about, okay? So we put an elaboration relation between these two. I don't actually, what's a marker for elaboration in PDTB? I don't know. Something like more specifically, would that count as one?
Specification.
Yeah, okay. Okay. And so the marker would be something like specifically, more specifically. Something like that. And you could put that in there, right? More specifically, the theory, blah, 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 right? So that would work. Notice there's something interesting here that I rushed over. Actually figuring out what the basic units are of the discourse structure is a little bit complicated. What we opted to do was we actually have one unit embedded in another. And you get this a lot in written text. I mean, in French we call them indices. I don't know what you call them in Czech, but they're like things like appositions, non-restrictive relative clauses. They're things that can move out from operator scope semantically. We know this from semantics. And this thing is really, you know, this is kind of an aside. And that's what's happening here. But it is inside this one. Now, why do I dwell on this? Well, because we've been working a lot on RST. RST does not have embedded EDUs within other EDUs. So what happens here? You have the theory of natural selection. That would be an EDU. It's just a noun phrase. This would be one. And then you'd have this verb phrase as an EDU also. That makes life much more complicated for our discourse parser if it's what it's expecting is some kind of event or clause-like object, right? Because I'm giving it a verb phrase, and I'm giving it a subject. The subject is not attached to the verb phrase. Okay. Anyway, so I wanted to just mention that. I'm sorry. And please tell me if I go on too long. I know I have too many slides, but I had a lot to tell you, so maybe that's... Anyway, the computation of the semantic scopes here. What does it mean for R to hold between these two things? Well, it just means that the interpretation of R holds between the interpretations of the two constituents. Just what you would think, you know, just what we learned from formal semantics. This is just a simple two-place predication. No fancy business. And then we can write it all out, we can write out this graph in logic, okay? And that's what I mean by transparent. What you see is what you get. You can write down the discourse structure as a piece of logic directly, you know, just translating arcs to predicates. Now, it's a very nice theory. I love my theory, but computationally, my colleagues say that trying to find these CDUs, these complex discourse units, is really hard. That we have no clue how to do it. So what we do is we eliminate them. And you get a dependency tree, at least in this case. Remember we had those, I'll just go back and show you. Here we had these complex constituents like this pi prime and this pi double prime. All that's gone away. And you're just left with the skeleton of the EDUs, and you've projected the relations that were on the CDUs onto their heads, which is either the top or the leftmost EDU. And it's a much simpler structure, right? You all see that. It has some drawbacks because these structures don't obey certain constraints that the ones with CDUs do, like the right frontier constraint. Let's look a little bit, just very briefly, at RST. Well, you have two types of relations. In SDRT, you have coordinate and subordinate relations. Here you have nucleus-satellite relations and multi-nuclear relations. Okay, now, it's a little bit unclear what nucleus and satellite was supposed to do, right? Somehow the nucleus is supposed to be the important part or something like that. You know, what's a multi-nuclear one? So they're all even, they're all have the same importance. Some people have used these in the computational literature. Most of the discourse parsers, or at least some of the discourse parsers, have used nuclearity decorations on edges to compute scopes of relations. And I'll show you how that works in the next slide. So here's an example from the RST tree bank. Okay, so you have, actually we reversed, yeah, no, this is right. So you have pi 1, then you have an explanation, you have a satellite here, it's an explanation, that involves pi4 and a restatement of pi2 and pi3. That's okay. So what is the scope of the attribution? Well, could be the whole thing, okay? But if you use something like Markow's mixed nuclearity principle, you would get this graph here. I mean, you get this into logic. You have restatement holds between pi2 and pi3, no surprise. Explanation holds between pi2, because you follow a nucleus chain down here, and pi4. And you have attribution between pi1 and, well, it really depends what you do here, but if you pick up this nuclear chain going down, you pick up pi2, okay? And it's a little bit complicated to figure out the details of the mixed nuclearity principle. In any case, that's kind of a weird reading of that sentence, right? It says that this is there, and it says that pi4 is not part of this, not in the scope of the attribution, right? They didn't say why they were delaying their proposed two-step expansion of the system. And that's not quite right? Because it sure sounds like, if you read that, how would you annotate that? If you were asked, what is the scope of, well, see, in PDTB, you don't have say, you don't have attributions as relations. But suppose you did. What would you take the second argument of the attribution to be? Does anybody want to hazard a guess? Yeah, right, the whole thing, including in the explication as well, right? You would agree? Yeah, that's my intuition too. So the principle didn't work so well here. But, so what we did was we played around with different other kinds of, and these are just the graphs again, with showing you, what you get on the two accounts. And you see how they're different. But the main point is probably not to go into, are you interested in sort of really looking at the nuts and bolts of nuclearity? None of you are really using RST here, right? Is that right? Not really. Okay. The main point is this, that we want to compare these kinds of theories, right? But in order to do that, we need a language that it can express semantic scopes in all discourse theories, in any kind of interpretation of those structures you take. Okay? And we need to be able to figure out, say, if RST is to be interpreted indirectly, we have to be able to describe how we're unpacking the argument, the real arguments in that structure. Now, what we did is, in this paper that was in Sigdial 2013, we actually gave, this is the way we thought of it. So it seems to us, we don't know of any structure that cannot be expressed in this kind of language. Basically, you have a list of relation instances and EDU instances, and each one of those gets tagged with a relation name, and you can also tag it with other kinds of information, and then you have to express inclusion in left and right scope respectively by these by two binary relations. And if we have a language where we can talk about sets of relation instances and sets of EDUs, we can write down, fully specify what RST does, what SDRT does, what dependency trees do, and we can show how to encode one within the other within constraints, and decode one from the other. So the theoretical part, we were worried about all these different theories out there. Once we have an expressive enough background language in which to compare them, that worry is in principle solved. Okay? And this is kind of what the encoding looks like. I won't bother you with that. I'll skip the weak dominance. And we could write down all the different interpretations for RSTs, for RST trees. But the basic results are these. Basically, if we have the immediate interpretation of RS tree, we can decode it immediately into an SDRS. The immediate interpretation gives us lots of CDUs, but we have those. We can also, if any interpretation amongst the set of so we tried to fix the mixed nuclearity principle, we relaxed it, and so what we get is a set of interpretations of an RST tree, and every one of those can be decoded into an SDRS as well. And so an interpretation of an RST tree then is a set of SDRSs under this decoding. And since the mixed nuclearity principle is always one of the, gives us a tree, gives us a structure that's one of the relaxed nuclearity principle interpretations, this is also strictly less expressive than SDRT. And the same is true modulo for dependency trees. So dependency trees and RST trees are both kind of underspecified versions of a fully specified discourse structure. That's what those translation results, that's what we showed. Okay. Yeah, oh, here's the slide with the, and there are some interesting differences. Dependency trees can represent things that RST trees can't. So RST has a really hard time with a bunch of multi-nuclear relations, each linking to the next. There's no tree that can construct that. But both RST and DT have these underspecified structures. And that means that parsing with RST or parsing with DT is simpler than parsing, than trying to find a fully specified scope structure for a discourse. Okay, well, so that was the background. So I'm now going to switch a little bit to just telling you about what we did with parsing. I mean, does anybody have any questions on the discourse part, or the theory part, or should I? You can continue. Okay, right, yeah, but just interrupt me anytime you want to. Okay, so we sort of now know, how to do discourse parsing, adapt discourse parsing experiments on SDRT or its DT version, and RST parsing experiments. And we're in the process of going back and forth on the two corpora. But what does parsing actually involve? Okay, parsing for a full discourse structure. Well, you got to have a corpus, you got to extract some features, you've got to do this segmentation, you've got to decide what your segments are, your basic segments are. And then there seem to be two kinds of tasks, but often they're lumped into one. Where do you attach, and how do you label that attachment? And we've taken a very naive view so far. There are more complicated versions out there, but which mostly rely just on things that have been done for sentential syntax. So our basic strategy is we have a local model which calculates the probabilities of attachments between all the EDUs that there are and the probabilities of those labels. And then we feed those into various kinds of decoders that can encode different kinds of constraints. There's a trivial decoder which is just the local model, which has a probability cutoff value. So if the probability of an arc with a label is, say, 0.5 or higher, infer that that arc exists in the structure with that label. Is that clear? Is that okay? Okay. What kind of decoding strategies do we have? Well, there are these greedy local kind of attachment strategies which say, let's look here at this basic level, let's put our best ones together, grab those, and then continue up the tree. there are certain transformation-based parsing strategies, like shift reduce, and ours was to use two different kinds of decoders. One is to use the maximal spanning tree of McDonald, which has been used in dependency parsing on syntax, and just gives you a tree. It gives you a tree that is best overall in terms of the probabilities on the labels and the arcs. That may mean that locally you may choose some arcs or labels that are suboptimal when you just consider two EDUs. And here's that strong baseline that I mentioned at the very beginning, which is just attach each unit to the last one. Okay? We also tried this A-star search algorithm, and we just put certain constraints on it. I think I'll skip that in the interests of time. So our first experiments were on ODs. It was very small. We had 18 relations. We grouped them, as many people do, into 4 main classes. And we had 2 locally trained classifiers, one for attachment, the others for the relations. And we trained 2 different types of probabilistic models. And we did the standard things. Models were trained on the 10-fold cross-validation on the document level. We had features that were very plain vanilla, and this is a real problem, okay? Because these are the features that our machine can understand. These are the features that most people, almost everybody uses, okay? People aren't using very fancy features. Are the 2 EDUs you're trying to attach to each other, are they in the same sentence? Is it the first EDU in a paragraph? How many tokens? How long, basically, is your EDU? How far apart are they? Is it embedded in another EDU? And then some other features, discourse markers, EDUs, apposition or relative clause. So we used a little bit of syntax there. The syntactic category of the head token. This was we tried to use some semantics here. We know that negation, tense agreement makes a difference. We didn't have enough information in French. There was no good co-reference tagged corpus. But for English, the Stanford Corel parser, Stanford parser also does co-reference, and we're experimenting with that now. So here are some results. Here's this is with naive Bayes, and this is with Maxent, and here's our baseline, last. It's really high, 62%. And we had trouble beating it, right? So here we're 3 percentage points ahead. Here, 4, almost. These 2 methods had similar results. They're certainly better than the greedy. And the confidence intervals are pretty good. Now this is kind of typical for work in discourse parsing. By and large, when you're doing the attachment problem, last is hard to beat. And Barbara DiEugenio had a last of 73% in her corpus, and she managed to eke out 73.1% for her classifier. She was struggling hard to do that. I could tell you why. The corpus was quite particular. It was cooking recipes. How do cooking recipes go, right? Cooking recipes, first, break the eggs into a bowl, mix the flour in, add the salt, right? It's sequential. And this is with the relations. Now, you say, oh my God, that looks terrible. But notice, this is a pipeline or a joint probability distribution. So this is essentially the product of the score on attachment times the score on labeling. And if attachment was 66% and we're only dropping down to 46%, that's pretty good, right? That means the labeling is actually pretty good. Over 4. Over 18, it's getting worse. I mean, you know, you can expect that. But over 4 general classes like cause, structural, thematic, that's pretty good. So that's sort of encouraging. It means that, you know, it's not a complete train wreck. There's some good stuff in here. If we only knew how to attach the things, we'd be in good shape. So, but we were disappointed. First of all, Anodis was a very small data set. So when we tried fancier methods, sort of methods that involve structural learning, we didn't get any payback. And the features we know are superficial, but you know, we'd love to have much deeper semantics in there, but there's a problem of sparsity, there's a problem also of being able to detect it. But as I said, the rhetorical label detection is not bad. And it seems like the main stumbling block is attachment. And we felt that our segmentation was pretty good. Why? Because our labels were pretty good. So let me contrast this with some of the best parsers, state-of-the-art parsers on RST. Okay, so the RST attachment scores are much higher, in the 70s. But remember, what does that mean? It doesn't mean that for us, when you make an attachment here, you know what the scope of your relation is. When you do attachment RST, you don't know anything. You have to first do attachment of spans, and then you have to compute nuclearity, and satellite labeling. That already bumps the score down quite a bit. But it's still higher than ours. But their labeling is in the same ballpark, right? Their labeling scores. So that means it's much harder for them to label than it is for us. So one of the morals you might take away from that is if you actually try to do the really hard attachment task, you know, getting full scopes, the EDUs that you're trying to attach to each other have the right kind of information to make the labeling task easier. Oh yeah, and then there was a sadder thing is then we were playing around with the local model with a cutoff value, and we started teasing, you know, tuning the cutoff value, and then our local model got very good. It just means our local model is pretty good, and our decoders aren't very good. Okay, well that's the story for discourse, for text, and I'm going to say a little bit about dialogue. Is that okay, or should I stop here? No, it's okay. Okay, so dialogue is different. Why is dialogue different? Well, text is a single author marshaling her thoughts together and putting forward the most coherent structure that she can. But in dialogue, let's say just between two people, somebody plays a discourse move, sends a message, then the partner or opponent decodes the message, thinking about the interests and beliefs of the agent, at least in standard game theory, and computes a very complicated problem. Namely, it tries to figure out exactly what the meaning is of this message in equilibrium. And then Y, she decides what signal to send and return, and then X decodes the message and goes through the same steps, right? So, but the main point here is not the little steps, but the idea that first X talks, then Y responds. Okay, so you get this. So conversations are sequential games and reactive games. We've done actually quite a bit of work on the theory, but it's not very computational, so I thought I'd skip it, but if you want to ask me about it, I'm happy to talk about it. But in order to sort of, there really aren't any discourse annotated corpora out there for dialogue at all, as far as we know. So we built one.
In Italy.
Ah?
Italy.
They have one?
Yeah, it's telephone conversation between people who bought product and online or.
But they use discourse structure, or they just do dialogue acts?
Yeah, they did it.
Ah, okay, I don't know that. But of course, that's not a full structure either. So we wanted the full structures, and we had data like this. So what we did is there's this game called Settlers of Catan, which maybe some of you have played. And there's an online version, and we modified it so that the players had to chat before they could trade. So this is a simple kind of discourse you might have. Do you have rock? I've got lots of wheat. And in fact, B has rock, he's just not saying it. So this is not a completely cooperative dialogue. So I'll give you 2 clay for a rock. How about 2 clay for a wheat? I'll give 1 clay for 3 wheat. Okay, it's a deal. So our dialogues are typically short, and this is what our chat participants are seeing. They're seeing a virtual board where they're building settlements and roads and settlements. And the way they do that is with resources like wood and sheep and stuff like that, or clay and wheat. But they often don't have the right resources to build what they want, so they have to trade with the others, hence the dialogues. And this is sort of, we know that we have quite a few of these structures in our discourse. So here's one. This is multi-party. So Gutwood for sheep, he's one of our most loquacious players. He talks a lot. Did anyone got wheat for a sheep? Sorry, not me. Nope, you seem to have lots of sheep. Yup, bah. I think I'd rather hang on to my wheat, I'm afraid. Okay, I'll take my chances there. So what's going on here? So he asks a question. He's kind of broadcasting an offer. And he gets 3 negative, he gets a negative response here, negative response here, and then there's a little interaction there, and another negative response. So I've just shortened this structure to have these 3 EDUs here, or these 3 turns, but here they're EDUs. These are turns in the dialogues. They're all answers to the question, hence the label question-answer pair. But then when he says KK, which I think means okay, I have to look at my Urban Dictionary because I'm really too old to understand this. I'll take my chances then. Who's he responding to intuitively? Everybody, right? He's acknowledging all the responses. So the natural what you see, what you get graph is to put an acknowledgement to each one of those negative answers. And now this is a multi-incoming edge structure to 239, no tree possible. Okay. And we have about 9% of these structures in the corpus. So, and you can see Anodis had 86 stories, and it took us 3 years to annotate them, and it was brutal. This corpus has 1,100 dialogues, 1,100 little texts. Okay, so much bigger. And we have a pretty nice annotation tool, and we have a much better annotator agreement here than before. In some ways, these structures are simpler because Okay. The structures are simpler. If I just go back to this little example, you see, there's not too, we could have segmented here, but we didn't. That might have been an error, but each turn is pretty much an EDU, okay? We do have some CDUs hanging around, but they're not in evidence here. So the turns really help us encapsulate stuff. And that the annotations have gone faster, and we've done better on them. Maybe we're just getting better at annotations. But then we have these very different structures, right? These lozenges. You'll never see a lozenge, I think, in RST. And I don't know, but given what Bonnie was saying, you do have multiple incoming links to a particular EDU. For the case like, but then, right? We bought the apartment, but then we rented it out. Because you have two relations to the same EDU. Right, and you can imagine having two different args incoming to the same EDU, but from different arguments. Visualize that? Something like this. I should have come up with an example. I mean, in principle, once you allow this, right, so, okay, those aren't tree structures either. But maybe people would argue about how to annotate those. I think it's really very difficult to annotate, to argue with the intuitive picture that you get for those, multiple acknowledgments to multiple parties. Okay, so we did do an annotation. We've been annotating these dialogues. We segmented them once again. We labeled. We did a two-level thing here. We tried to do something traditional, sort of. We tried to annotate the dialogue EDUs with kind of these unary speech acts, negotiation moves. So we called some offers, some counter offers, some were accepts, some were rejects. And then we did the relational structure on top of it. So our annotation campaign has two levels here. Here are the domain level acts, not many. There were a lot of others. Because these guys talk a lot, not just about the game, but what movie to go see, who's dating whom, and so on. Sorry, this slide didn't work out so well. This was just trying to show you. There's some pretty wild things, right? So here's a alt-lex formulation for you. And I alt-tab back from the tutorial, meaning, well, I haven't been paying attention, so fill me in. And then you could think of all of this as kind of a marker. And it says, what's up? And so, you have the domain function here. Then you have the rhetorical functions over there, but they can't see them. I'm sorry that I didn't do that very well. Okay, so we have this annotated resource. So how do we do on parsing on this? So we know that these non-tree-like structures are in there. We also have another phenomenon, which is some people don't believe exists, where you'll have A will be talking to B. So you'll have something like this. Then, A will just forget about what C said. B will, and C might insist. She might come in and say, no, I don't know. And then B is going to pick up maybe on what he said, something like that. So we get very complicated threads of conversation where we have sub-conversations that are crossing. And so we have long-distance crossing dependencies. And this is a much more complicated structure than we had before. To deal with these kinds of things, we need different sorts of decoders. And so far, we haven't done very well. I should say that in general, given how that these the decoders that people are using, including us, are based on sentential syntax, where do you think they do best? What discourse structure do they do best on? Intrasentential discourse structure. They do pretty well there. You know, outside, it's we're not doing well. So what we're trying two different ways. We're trying to augment the tree structures. So we take, we like MST, let's say, or A star. We take the core, and then we try and add stuff to it. The other approach, which is much wilder, is we know we have DAGs, and we know that our structures are DAGs, directed acyclic graphs. Well, let's just take the maximal spanning one. And we know how to compute that. And then we have to thin it. It looks pretty much like a pile of spaghetti, right? Everything is connected to everything. At least there are no cycles in it. And so we've been experimenting with integer linear programming to thin out our DAGs. And I'll just show you our results that we've submitted to ACL. As far as we know, nobody else has tried this on Discourse, on Dialogue. So our MSDAG really kind of failed miserably. He did great on recall, 94.7% recall, but 11.5% precision. He's very permissive. And the ILP bumped the precision up quite a bit. We lost some quite a bit in recall too. The champion was MST with adding certain structures, like for these lozenges. But notice that, here too, even though we're just starting, we're kind of in the low 60s, in the 60% range for the attachment problem. And we're not doing so badly on relations. We're comparable to, what we the best things that are done in text on relation identification. So the methods that we've already been using do extend to dialogue. We could do dialogue processing, and we're not that much worse than we were with text. It's just that and we're pretty good on labeling in both cases. We're pretty good, right? We dropped from 60 to 42% in F-score. That's not a bad drop, right? Means that we're, doing really pretty well. However, we're just not doing very well on attachment in either domain. That is, when we're trying to build a complete non-labeled graph for a text or a dialogue, we're coming up against the same hurdle somewhere in the 60s. But we're trying to play this game, we're trying to be very precise about what the scopes of the relation are, or each relation is. And I feel that we certainly need better features. We need deeper features, but we also need a better understanding of the structures and the constraints on them, and we need to build decoders that aren't just syntax decoders, but are semantic and discourse decoders that will be able to capitalize on those constraints. And that's about my message for you. Thanks for listening. Yeah, I'd like to hear about what you've been doing too. Please. Oh, I can hear you. Oh, but this is to be recorded. Yeah.
So I'm Lucie Poláková. So just to be clear, I have like tens of questions, but this is actually the first time we actually meet SDRT more than just what we have read from the books we have available. So thank you very much for this talk. But since this is the first touch, it was a little maybe
Too fast.
too fast, or
Okay, so what would you like me to go into?
no. I just wanted to clarify a few things, and I will be really talking from the PDTB point of view, not really knowing the details about the structure-based approaches. So I would be interested, and you said that the RST had better numbers for the units attachment than you had. And the labeling numbers were then
Very comparable.
Equal. So I was wondering if the definition you used for the elementary discourse units, or maybe the elementary units, was the same in RST and for you, because maybe it depends what you take to be the basic unit for the attachment.
Right.
And since you have this example with the very first noun phrase on the top, the principle of whatever it was.
Natural selection. Here, I'll bring it back.
Yeah, so it actually implies that you really use non-event or just entities as your elementary units or arguments. So I would be very interested in knowing what actually do you use, both in the theory and then in the parsing.
Right. So,
Because one more remark, because we actually all use your delimitation of an abstract object here as a basic discourse unit.
Right. Well, this is an abstract object, really. I mean, it denotes an NP, right? It's an NP, and it's principles, right? It's about principles, right? So we would take it to be an abstract object too. You almost could think of it as a clause. So our basic intuition about EDUs is that they do exist underneath the clausal level, and they can either be things like, almost like titles, which is what this is. They can be appositions. They can be relative clauses, okay? But they're also marked typically by we're very happy with the punctuation too. So so basically each one of these has to be some sort of an event or abstract object, okay? Now, how do we find them? Well, punctuation is not a bad tool. We use punctuation on STAC, on those games of Settlers of Catan, and I go over it manually, but I don't have to correct it so often. It's really quite good. But the punctuation here is important, right? Because this means that, in some sense, this is a full thought. It's something like, I'm going to tell you about the principles of natural selection, right? And then we also have, notice that this one here, insofar as it was initially described by Charles Darwin, it really is a full clause.
Yeah, we don't have a problem with that.
Right. And then we have a full clause over here. So we have something, but we have something embedded. And I don't know whether in PDTB you have embedded things like that.
I think we do. They can go separate arguments.
Okay. RST does not have those.
In the parsing experiments.
In the when they chop stuff into EDUs, this would be an EDU, and this would be an EDU, and that gives our parser fits and conniptions. And there are worse things too. There's like, Eva, who invited me to Prague, is a famous linguist. It's true. Now, we would all segment this. RST would do it too. But what they would leave that. And notice that is very different from that intuitively.
Yeah, that was my question actually.
Right? This thing is bad, and this is worse for us. So RST uses this relation called same segment a lot. and we do very badly on same segment. Our features are not attuned to recognizing same segment. We don't have enough syntax in there. If we put more syntax in, I feel confident we'll do that. But this is not really a discourse relation. Same segment is not a discourse relation, it's an artifact. I'm for just throwing those out and having EDUs put together. So if you put a lot of syntax in, you know, probably you'll get these two things together. Now they have Penn tree bank parses, but there are some weird things that I did want to ask you all about. I'm not going to be able to dredge up this example from memory, but it's something like this. You have some adjunct over here, but then, and then you have I don't know, maybe some kind of relative clause, and here's the verb. And what happens is RST segmentation does this. So this is, maybe it's a VP, think of it. And what they do is they include, no, it might be, I'm sorry, this is a verb. I think it's this bad, that you have segments like that. So where the adjunct somehow they wanted to make the adjunct into another segment. They were right to do that. But for some reason, they put the direct object or something much closer to the arguments of the verb into that segment. And once again, I submit there's going to be very little kind of coherent discourse relation that's going to go between an argument and its, you know, and the verb. But if you have lots of syntax, you get these things right. So in some ways they're doing, you know, you're absolutely right that the segmentation is very important here and what resources you should throw at it. Because we think of it as a semantic problem, we're totally perplexed by this. When they don't think of it as a semantic problem, but just sort of an extension of syntax, they're not bothered, just say, oh yeah. And they do actually very well inside the sentence, given their, from my perspective, crazy CDUs. But I think my CDUs, or SDRT CDUs, are pretty close to what PDTB wants, except I don't know what you do with headlines. Maybe you don't actually.
We actually have headlines as the only span that don't have to be really clauses or. Okay, well that's
actually that's what that is, yeah. Right? But we just made that into a EDU. Yeah. So the rest of them are, well, these are interesting too, right? These, but we have this colon, and we segmented these three principles now, right? But they were all. This is a very specific. Discourse device, right? Here you're signaling that you're going to have three principles and then you spell them out.
A list structure.
Sorry?
They would call it a list structure.
Right, and we had them as continuations underneath, you know, that are elaborating this pi 2. Okay, so yeah, in some ways I think that what SDRT has done with EDUs is certainly closer to what, you know, PDTB has done. I don't think you would ever do that. Nor would you leave Ava by herself as an EDU. Now, why are they forced to do that? Well, that's because they don't have embedded EDUs. Okay, so I think embedded EDUs are a really useful device and have to be used, or else you're going to get a lot of discourse relations that aren't discourse. I mean, I don't know, what possible discourse connector or altlex thing could you put in there? Or attach these two things, right? Ava is a famous linguist. You don't have anything, and we don't have anything either. And so our machine is completely, confused by these things. Sorry,
okay, thank you. Yeah.
Was that okay? And I mean, we can come back to the other questions too, but certainly the EDUs are important, and you're right to sort of think about it, and the fact that they very heavily use the Penn tree bank syntax. They actually, the best parsers for RST actually use syntactic structures like kernels or perceptron Myra type structures to look at the structure of take the syntactic structure very heavily into account. But that means outside the sentence, they're not doing very well.
So, I don't know, is that the only question of that?
Oh, I hope not.
Maybe a rather technical question. Did you measure learning curves?
Oh, sorry.
Did you measure learning curves?
Oh, right. Well, we know we haven't done that for STAC, and that's where it would make sense to do it.
Because I'm asking because at the end you mentioned that the way to go now is to add some more features. So always there's a choice whether add more data or search for a better algorithm or improve features.
Right.
So you have some intuition saying that the third one is the way to go.
We have a lot of data. I mean, 11,000, 1,100 texts. That's a lot of data.
Yeah, but if
you have 4 relations.
But in a restricted area, actually.
Yeah, it's also in a restricted area. We should be able to learn off those. At least, I mean, you're right that it's just so expensive to get this data. It's really, really, really expensive.
But you don't have only to increase the data, but you can use also 1/2 of them and 1/4 of them to see whether maybe you have been saturated with half of the data already.
Right. No, well, we did do such an experiment. Well, Anodis was just too small. 86 stories, it's just not enough text. And we actually did pretty well on 86 stories. We have looked at that preliminary fashion in STAC, and I can't remember. Yeah, it's a good question, and I can't remember what we concluded. And it may be part of the root of my intuition that I need better features. But you can also see the features are very superficial, right? And when you think about, so if you work on the PDTB or the Czech tree bank, do you work on the Czech tree bank?
On the tree bank, not on the discourse part.
On the tree bank. All right. So, right. But if were you to do try to figure out whether to put in a because or as a result kind of marker, you're actually thinking quite a lot about the meaning of the two sentences. At least that's the way it feels intuitively. And none of those constraints really gets at anything like the meaning. So I have a student who's compiled this huge database of verbs from GigaWord and UKWAC and FRWAC. So we're looking at pairs of verbs and the discourse markers from the PDTB. See what verbs go with what markers more often than not. And over 2 or 3 billion words of data, you start to get some information. We're just assuming attached to last, but we know that's a pretty good baseline. And so that kind of information potentially can help, but it's also very noisy data, and we don't quite know how to use that resource yet. But it's an interesting resource, and it's kind of that kind of thing that I'm thinking of. In my little head, what I'd love is, for the machine to give me a logical form here, a logical form here, and then do some inferences off them and say, oh yes, so the best relation is, of course, explanation. But that's pie in the sky. But you're right, we should, I'll try and dig up those things. Maybe I even have them somewhere on my computer, but thank you for the question.
Oh, this is just a very tiny question concerning the character of the data for the dialogue. It seemed to me that what you have is one type of dialogues. Just something similar to what used to be the task dialogues for some research. So I don't know, is it the example you gave us somehow hinted to this
No,
question?
Let me see if I can, hold on, I got to get out of this. I'm going to do something scary. I'm going to try and open up the annotation tool, but I need my glasses. Sorry, let's see if I can show you. It's a lot wilder than that. I gave you a very nice vanilla example. But what I wanted to show you were those lozenge structures. But if you just bear with me here for just 1 minute. You see how terrible my setup is. Come on, open. Oh, okay, he's going to open. So what do I have in here right now? Can you see that at all? Does it, let's see if I can't put some pretty colors in it. Okay, so this is like an opening.
Okay. Yeah.
Evening, hey, how are you today? Hi, not bad, thank you. Hey, yeah, pretty good. And we get
So it's not.
getting a bit of deja vu here. Great minds think. He says he's coming. So there's a lot of greeting going on here at the beginning. There's quite a bit of negotiation, but there's also, I mean, look at this one. Do anyone need ore? I'll trade for sheep. Yes, thank you. Cool. Oh, I'm okay for ore. But see, so they're actually doing the trade while these people are talking. So it's not a cooperative task at first. So there it's quite different from task dialogues. The domain is kind of limited, and we're trying to exploit that. But they also, as you saw, they have discussions about waiting for each other. There's lots of greeting. Then there's discussions of strategies.
Yes. Then
Then there's discussions of movies. And so it's actually quite a bit more general. And here's a CDU here, a small one. But yeah, these structures are, and they're also, this is a pretty long distance dependency for dialogue. So it's not immediately reactive, but that's because these guys are having their own little conversation, and then these people are chiming in way later. We actually have, we have the entire game state recorded, so we can actually play the whole game back if we want to. And sometimes we don't know what they're talking about, and we actually have to look at the game state itself. So there's a whole nother aspect of this which is extremely interesting, which is how much can you get from just overhearing the conversation about this game? It turns out you're missing quite a bit. So we have a paper at IWCS on that point where we show up to 20% of the EDUs needed to understand what's going on in the dialogue are not even verbal, but they're somehow given by the picture. This kind of weird picture, the game state that I had. Let me go. I think I can do this, can I? I'll open Prague here, and yes, this picture. This actually, this thing is dynamically evolving. So as they're talking here, things are being built. There's also a robber somewhere, this guy. He's being moved around, and they're talking about things that are happening in the visual display, as well as talking about other people's moves. And sometimes they make moves without language. They're not supposed to, but they actually sometimes make offers non-linguistically.
Well, I asked because we had some experience with Ivana Korbayova when we tried to apply our approach to the hierarchy of activation of elements in a discourse, and we tried to apply it to dialogue, but we didn't have real dialogues, I mean, in the sense like task dialogue, but we took some dialogues from plays, from drama. And it was quite clear that the issue of coherence was different from the issue of coherence in monologues. Monologues were much more coherent. You could follow the activation more easily, while in dialogues, I mean, people, even if it was, I mean, in a play on one topic, so people could go to different things. Also, the sounds were important, so the context, not just co-text, but the context was important.
Right, that's what we've seen too.
Different.
And so I should say, so the right frontier constraint, which is pretty strong in text. So I should say a little bit about that because it was kind of interesting. Our first annotation experiment on InnoDis was one where we took 3 undergraduates and we didn't tell them anything about the structural principles of the theory because we wanted to kind of see what was in their head. We told them about the relations. We told them, you know, try and find these relations. You can, if you feel like, you know, several of these units that we've given you, we gave them the segmentation. Several of these units are playing a role together. You can make a blob out of them and say that those are, say, an explanation of, you know, of this other unit. And we didn't tell them anything about the right frontier. And we found that once we untangled all their messes, because they kept on putting the relations backwards, it's actually quite hard to draw these arrows. You know, you have to start from here to get the arrow to go here, but if you go this way, the arrow is reversed. But once we did that, we found that something like 92% of their attachments respected the right frontier, which was, we published that as Coling in 2010. We were like pretty blown away by that because, whoa, they are actually doing this in their heads. So the right frontier is where roughly, if I have a graph something like this, and that was the last element entered, this is available for attachment, this big guy is available for attachment, and this guy. But these are not available for attachment. And that was a pretty strong principle in text. But here, you have to relativize the right frontier to threads of speakers, because these people are having their own conversation, and these people are just chiming in later. I mean, if you thought of this sequentially, you know, the trade's over. So what are these guys doing? Well, they just weren't paying attention. But one version of the right frontier constraint would say that all these things were off, because the trade's already concluded, it's done, it's over with. But no. So yeah, coherence is a much more complicated affair in dialogue. And people seem to be able to interrupt and come in whenever they want to, like the person says, and I alt-tab back from the tutorial. He hasn't been saying anything for 30 or 40 turns, and then he just comes back, says, what's up? Then somebody said, you were supposed to trade, you know, about several turns ago. No.
So,
sorry.
Some further questions? Open?
Yeah, maybe a very
Yes.
basic one.
Sure.
What are the discourse relations supposed to hold between in your approach? Are they, do they hold between meanings or contents, or the facts expressed, or the contents presented by the speaker?
They hold between content occurrences. And there's a reason for that. So if I switch over to this picture, sorry, just this guy here, for example. These labels are occurrences of contents, just like Kaplan thought he was giving the semantics of occurrences of sentence in a particular non-linguistic context. Now, why do I say, why are occurrences here? They are, I mean, they're intimately linked to contents, but these are occurrences because you could have the same content appear in several different places in your discourse and bear different relations, maybe incompatible relations to EDUs. Okay. And you don't want the discourse thereby to be inconsistent. So that's what these things are. They're occurrences of content, okay? So I could repeat, you know, I'm hungry, I'm hungry, I'm hungry, I'm hungry, right? And it's not just, it's different from just saying I'm hungry, right? So I have a small child, and around 6 o'clock in the evening, I'm hungry, I'm hungry, I'm hungry, I'm hungry. And if you don't do something very soon, there's going to be an explosion. And it's very different from just saying I'm hungry once. And you know, we need to take account of that in our discourse structure. Does that kind of example make sense to you? But the content is, of course, crucial, right? And the fact that she's repeating the content is also crucial. But we need that repetition. So if it were just the abstract object alone, we couldn't get the repetition. Does that make sense to the... So, I mean, we all agree that what's crucial here is the abstract object content that's associated with this occurrence. I mean, I don't care about the, you know, how it's written or, and we don't, I mean, Eva would be better at this than I, but we don't do anything with prosody. We don't actually do anything with spoken text at all or dialogue. It's a major, huge issue and very difficult. It's also very difficult just for privacy issues. I mean, those of you who have to deal with, if you have to deal with EU regulations, this applies to you cost people. If you want to do prosody, it's very difficult to mask the person's voice so that they can't be recognized. Mats Ruth told me it's actually impossible nowadays with, you know, the data. The voice identification software is too good, so you're kind of screwed when you're doing this. You know, but it's very important. It's extremely important to look at that, but it's so much harder. The annotation task is so much harder. Just doing the transcription from, you know, voice stream is horrible. Okay, yeah, so that answered your question.
So, if there are no questions at this point, so let me thank you again for your coming here, for your effort, for your energy, and actually I'm sure at least some of us will be meeting you at the COST seminars, workshops, or meetings in the future of 3 years or 2 or 3 years. So thank you very much again.
And